I'm Anil Kumar. Let me thank all my viewers and subscribers for posting excellent questions and sharing their test questions. Here is a question from one of our subscribers. It is based on calculus relative rates of change. Question number 3. The motion of a particle is described by the function s of t equals to t cubed minus 12t squared plus 45t plus 3, where t is greater than or equal to 0, where time t is measured in seconds and s in meters. Now it has 5 parts. You need to figure out when is the particle at rest, when is the object moving in the negative direction, when is the acceleration positive, is the particle moving towards or away from its initial position when the acceleration is 0, and is to find total distance traveled in the first 8 seconds. You can always pause the video, answer the question, and then look into my suggestions. Now this is displacement velocity acceleration application. Let's begin with the displacement function, which is s of t equals to t cubed minus 12t squared plus 45t plus 3. Derivative of this will give us the velocity, right? So velocity is equals to derivative of displacement, which will be 3t squared minus 24t plus 45. Now let's factor this. So we get 3 common. We get t squared minus 8t plus 15. Now 15, that means 5 times 3, so we could even factor this, t minus 5 times t minus 3. So that becomes the velocity function. Now part A, when is the particle at rest? So at rest, we know velocity is 0, right? So part A, v of t should be equal to 0 at rest. And that gives you 2 positions. If I equate this to 0, t equals to 3 and 5, right? T equals to 3 and t equals to 5. These are the 2 solutions. Perfect. Part B. When is the object moving in the negative direction? Now, negative direction, we have to figure out when is velocity negative, correct? So that is to say, what we could do is, we can analyze the zeros. Okay, so let's say we'll make a table and then figure it out. So let's say this is at t equals to 3, this is at 5. Let's take test points, correct? So 0, 4, and 6 could be test points. And then we have our factors, which is t minus 5 times t minus 3 times 3. Let's say velocity, right? If I substitute 0 here for t, I get negative negative as positive, correct? If I substitute 4, in that case, this will be negative and this will be positive. And negative and positive will give me negative. And if I substitute 5, 6, in that case, both are going to be positive. This is one way of doing it. The other way is that you could sketch the graph, right? You know these 2 zeros. Leading coefficient is positive, so you are expecting a parabola which is going through both the zeros, kind of like this. So it is the interval between 3 and 5 when the velocity is negative. So when we say, when is the object moving in the negative direction? So it is from t equals to, let me write here, this is when t is greater than 3 and is less than 5. So this is the time when the particle or the object is moving in negative direction, or we can say v of t is less than 0, correct? So that is the part B answer. Okay, I hope this is absolutely clear, right? Now let's look into part C. When is the acceleration positive? So let's find the acceleration, which is derivative of the velocity, right? So we'll use this particular expression. The derivative of this velocity will be 2t minus 8, correct? Which I can factor 2 out, it becomes 6 here, and so we get t minus 4. So when is acceleration positive? This is a straight line, correct? So as you can see, the acceleration is kind of a straight line. And what do you notice here? That the x-intercept, or it is 0 at 4, right? So it is 0 at 4. So it is positive after 4. So we see that acceleration t is greater than 0. That means t is greater than 4, correct? So when is acceleration positive? We can say when time is greater than 4, correct? So that is how you could answer this part. Part D is the particle moving towards or away from its initial position when the acceleration is 0? That means we need to analyze this point 0. And at this point, whether it is moving towards or away from its initial position. So I'd like you to pause the video, answer this part and also part E, and then look into my suggestions. I'll take up these solutions in a fresh page. Okay? So now let us consider part D. Is the particle moving towards or away from its initial position when the acceleration is 0? So as far as part D is concerned, we found that acceleration equals to 0 at t equals to 4, correct? So for moving away and towards, the condition here is that the product of displacement and velocity, if it is greater than 0, then it is away, right? But if this product s of t, let me write here, if s of t and v of t is less than 0, then it is towards initial point. Is that clear? So we need to consider the position and the velocity, both of them at t equals to 4, correct? That is kind of very important. So we already have s of t. So let me write the value at 4. So which will be equals to 4 cubed minus 12 times 4 square plus 45 times 4 plus 3. So let's use calculator to calculate this value. So it is 4 cubed minus 12 times 4 square plus 45 times 4 plus 3. This is equal to 55. So this is positive 55. Now, what was the velocity? Let's calculate velocity at 4. Well, let me write the expression for velocity first, which is 3. We remember, right, 3 times, in the factored form, we wrote t minus 5 times t minus 3, correct? This is simpler. So at 4, I could replace 4 and then it's easy to calculate 4 minus 3. This is negative and that is positive. So we get minus 3, which is negative. So as you can see here, the product of velocity at 4 and displacement at 4 is basically minus 3 times 55. And this is less than 0. And therefore, we can say the object is moving towards initial point. Is that clear, right? So that is how you're going to answer this question. It's kind of very critical to understand, and I hope this particular knowledge helps you to answer similar questions. Now let's look into part E. Find the total distance. It is not displacement, total distance in first 8 seconds. So what we know here is that the object actually starts at 3, it moves and then it turns and then turns back. And these turning points are at t equals to 3 and 5. So at t equals to 3, it turns, and at t equals to 5, again it turns. And this position here is at t equals to 0, s is equals to 3, right? So if I substitute 0 here, we get s equals to 3. We should now find the displacement at 3 and 5 and also at 8, correct? So let's calculate. So we'll find what is the value of s at 3. So we'll substitute 3 here, which is 3 cube minus 12 times 3 square plus 45 times 3 plus 3 equals 2, correct? So let's use the calculator. 3 cube minus 12 times 3 square plus 45 times 3 plus 3 equals 2, 57, right? Now at s equals to 5, we'll just replace 3 with 5, correct? And recalculate. And that is equals to 53. Now at s equals to 8, what is the position? We'll again replace 5 with 8 now. So the displacement at 8, t equals to 8, is equal to, we're changing 5 to 8. So I hope you understand what I'm trying to do. The figure is there in the calculator, so I'm just changing 5 to 8. We get 107 here, okay? Well, there could be calculation errors, but you should do these calculations on your own, right? So t equals to 8, we get s equals to 107. Now, it is easy to find total distance traveled in 8 seconds, right? So distance in 8 seconds is equal to sum of all this, right? So we calculated from here to here is how much. So it is 57 minus 3, sorry. So we could write this as, this distance is here, s is equals to 57, correct? So 57 minus 3, so that gives you 54. And then here we had at t equals to 5, 53, so that means this is 4 units, and then 107 minus this. So this is basically equal to the value, right? So it is 57 minus 3 plus, then this is absolute values of 57 minus 53 plus 107 minus 53. Correct? These check the absolute values. That should be okay. So let's calculate this. So we have 57 minus 3 plus, so I'll take away from the bigger value, right? We'll write this as 4 plus 107 minus 53. So that gives you 112 units. It is in meters. So the total distance covered is 112 meters. So whenever you're trying to find the distance, remember, you need to check turning points and add absolute distances. As we did here. Do you see that? So that is how you actually solve this question. I hope it helps. So feel free to write your comments, share your views, and if you like and subscribe to my videos, that will be great. Thanks for watching and all the best.